In this video, we're going to discuss the statistics of coin flips. So we're going to start out with 3 coins and we're going to flip each of them once, and we are going to figure out how many possible outcomes are there of flipping 3 coins. So I've actually written all of the possible outcomes here in terms of heads and tails. These are all of the possible microstates of the system, all of the unique ways of rearranging our coin flips, right? So we could have 3 heads, we could have 3 tails, we could have a heads, and then a tails, or a heads, and then a tails, and then a heads. Each of these states represents a microstate. There are 8 of these, so there are 8 total microstates. The way that we can quickly calculate this 8 number is that it is simply 2 to the number of coins that we flipped. So in this case, 2 to the 3 is 8. The way to think about that number is simply to say, well, I have 2 possibilities here multiplied by 2 possibilities here multiplied by 2 possibilities here, etc. If I flipped n number of coins, I would get 2 to the n. So if I have 100 coins, that's 2 to the 100 possible microstates, possible unique combinations of heads and tails that I could get. Now we'd like to consider the macrostates of this 3 coin flip system. So a macrostate is going to be defined as the combination of how many heads do we have and how many tails do we have. So 2 heads and 1 tail, that is a macrostate. It has 3 microstates associated with it. There are 3 different ways of rearranging 2 heads and 1 tail. That makes up the number of microstates in that macrostate. So in this system, we have 4 possible macrostates. We have all heads, 2 heads and 1 tail, 2 tails and 1 head, and 3 tails. So what we'd like to be able to do is figure out what is the most likely macrostate, the most likely combination of heads and tails, and that will be the one that has the most microstates. So just from our list here, we can tell that these 2 macrostates, 2 heads and 1 tail and 2 tails and 1 head, each have 3 microstates associated with them, and therefore will be 3 times more likely to be found than the other 2 macrostates where we have only tails or only heads. Now, we can calculate the probability of finding a given macrostate by taking the number of microstates that macrostate has. So in this case, we have 3 if we're looking at 2 heads and 1 tail. We have 3 total microstates for that macrostate, for 2 heads and 1 tail. And then we divide it by the total number of microstates, which is 8. In general, we can write this using our combinatorics relation here. So this numerator here gives us the total number of ways of rearranging 2 heads and 1 tail. It is 3 factorial, the number of objects that you are rearranging, divided by how many heads do you have and how many tails do you have, each factorial. If you need a review of this equation, you can look at the Intro to Combinatorics video where we talk about it in depth. Now, we can expand this to a system where we have n number of coin flips, say 100 or 1 million or 10 million, right? We can find the probability of some particular micro or macro state of some combination of heads and tails as being n factorial divided by the number of heads factorial times the number of tails factorial. So this represents our 3 factorial divided by 2 factorial times 1 factorial in this example. And then we've taken the 2 to the n and moved it here into the denominator. This is exactly the same mathematics. It's just a little cleaner to write it this way. So we have the number of ways of rearranging our heads and tails given by these factorial terms, and then it is divided by the total number of possible microstates, right, which is 2 to the n if we have n coins.